Hey guys, a friend stopped by tonight that I hadn't seen in quite a while. We had a good time catching up, and he dropped off the scope. So I thought I would do a quick video while we check it out for the first time. He told me about this a while ago, some years ago, and we just haven't been able to get together until tonight. And here it is. It is a Tektronix 454A. Now, you've been probably used to seeing me use that HP digital scope for years now. I do actually have some analog scopes. I do have a 465, which works fine, although it needs to be calibrated. I think this has a little bit better specs. This is a dual 150 megahertz scope, whereas the 465 is 100 megahertz. Do not know if it works, but it's got some condition issues. So in this video, I hope to do a preliminary look over and see if we even can try to power this up. So right away, I can see it's been kicked around a little. It's got some codes and markings on it, so it's probably out of a school or a lab or something like that. Biggest problem cosmetically is the feet. There's only 1 foot left on the bottom, and the back is really messed up. There should be 4 feet, kind of this hard rubber material, and the cord would wrap around them. There should be 1 in each corner. So there's a little bit of it left. 2 of them are obliterated, and this one got annihilated. But worse, it took something out. It looks like there's some sort of potentiometer back there. Maybe some kind of internal calibration or something. And it's gone. And a chunk of aluminum is gone. So even if I got a new foot, there's nothing to screw it into. It should have a mount like that. Instead, we've got nothing. But at least if it had 3 feet, it would sort of balance, and I could glue something on. I could pound out this indent too. Let's see what's holding this back on. I guess I just got to take the remains of this foot off, and this back will come out. And maybe I got to take this off too, because I want to pound that out so it doesn't short into anything, and try to figure out what that pot was, and try to replace it. The power cord is mangled, which is a good thing because it maybe increases the chance that it hasn't been plugged in since that damage was done. I think that could just be crimped and made usable, except it looks like the ground, I'm sure this was grounded originally because there's 3 wires going to it. There's no ground pin. I don't know if it was cut off, ripped off, whatever. So I think we should replace this line cord as well, although we could try powering it up without that ground pin present. There's a little deal here in the back to dial in your line voltage. So it looks, I don't know how exactly this thing works. If you take these off, maybe there's a little plug. You can move these plugs around or something. But it looks like we're on the 115 range, 104 to 126, so that is all correct. I'm doing this on the floor for a reason, by the way, because it's carpeted and this thing is messed up, and I don't want to be banging it around on the workbench. And I apologize for doing it free-handed, but I don't want to try to setting up a tripod while I'm exploring this. It's just going to lead to terrible camera angles. Wow, that if you haven't seen it before, that is what a late 60s, early 70s scope technology looks like. Transistors for the most part, but I believe this has some new Vistors in the front end. Those are tubes that kind of look like about that size. They're sort of transistor looking, but they are tubes. Now, I've never serviced a scope like this. I've read about it. I've seen it done. I know it can be a challenge because of all the hand-selected, specialty, matched, exotic components. At least it doesn't look as bad as Hewlett-Packard, where everything would have a house number, proprietary number on it. At least, like these transistors are 2N3495. At least I understand what that means. Pretty though. Looks like they're gold washed circuit boards. Every transistor appears to be socketed. A range of styles, from little plastic domed ones to little metal ones. I've never quite seen anything like that before. More conventional packaging style on those guys. And then some like that, where that's for getting into this exotic stuff, where that was probably not just for heat sinking, but to thermally match those two components. All these white tubular things with stripes, I believe those are ceramic caps. They may very well have magic temperature coefficients. Looks like a weird kind of bodge job on that, but that may very well have an engineering significance to how they laid that out. Whole bunch of precision resistors. Now on the plus side, I don't see anything damaged. I don't see anything that's burned out or fried or smashed or any of that. This bottom looks to be in fine condition. Danger high voltage, that will be where the high voltage is created. The only reason I think this has new Vistors in it is when I went on eBay and did a search for a Tektronix 454 to see what kind of parts might be available for it. And somebody was selling like hand-selected matched new Vistors for this. So that's why I presume there are some somewhere. So this ain't the whole scope we're looking at. This is the bottom layer. There's going to be a whole top layer too. Let's look at that next. I believe what we just looked at was mostly the vertical amplifiers for the two channels. On the side here, what is this? Stigmatism, gate, current probe calculation. Looks kind of like some specialty stuff. Let's see if the top comes open. Oh, look at that. Let's see, what do we got here? Wow, that must be the power supply. Those are some very fancy looking capacitors. They have little plastic jackets on them. Wow. Why? Maybe for airflow? I mean, why make such a complicated plastic mounting just for some electrolytic capacitors? I don't do much test equipment. And the stuff I've done is generally like really old stuff, tube testers that are nothing like this. I haven't done a whole lot of really semiconductor stuff. Mainly because, yikes. Like I do have a 465. I looked at the calibration procedure for it, and my God, I mean that's like that was a full-time profession back in the day. It's dozens and dozens of pages of stuff to go through. I don't even have all the equipment to do it. So I would be happy if it worked and worked within like 20%. I don't need it to be precisely calibrated for the kind of stuff that I do. Like when I'm working on an old TV, I just want to see, is there a video signal getting through? I don't care about down to the 100th of a volt what the amplitude of the signal is. There are services out there, I do believe, where I could send this off to if I wanted to. Although it'd probably be a lot more practical just to buy one that's been refurbished already. Huh, an odd little thingamajig. I wonder if that's a delay line. There's a little inner thing and then like a spiraling outward thing to another connector to a little bit of wire. What's that going to? Coupling. I did download the user's manual for this, which is many pages. It does have a schematic. I did not see a service manual though, which could be a drag. It looks like there are some test points here and there, maybe like that. Like that. I see that should be plus 75 volts, I think. So this is a regulator board. So it'd probably be good to at least know some key stuff, assuming this thing turns on, we get a trace, is to at least calibrate the voltage so at least the power supply is accurate. That should be fairly easy to do. Just plus 12 volts, plus 75. Don't see any that are plus and minus 12 volts and plus 75. I wonder what those are. Could those be new Vistors? No, it looks like they have Q's for the part numbers. If there are any, they're probably inside that metal box down below, right off of the inputs. Well, alright, let's focus on that part that has damage. Holy cow, now we're getting into the really exotic stuff. Man, check that out. You'd think that that would have been encased inside of something, and maybe it was, but it's not now. That is some like thick film hybrid technology. Apparently somewhere in there are 2 transistors that do something very special, I'm sure. This does say main vertical amplifier. One thing I'm not sure about, just from looking at the cathode ray tube, is does this have 2 sets of deflection plates? There's 2 ways to do a 2-channel scope. One is to have 2 sets of deflection plates and 2 separate amplifiers and everything's completely separate. And 2 electron guns. Basically, it's a picture tube or cathode ray tube with 2 electron guns that operate independently and deflect independently. Or you chop it, meaning there's only 1 electron gun, but you rapidly flip between 2 signals. And to do that, you need a very high-speed switching thingy, which is what this could be. Although I would think for a scope like this, it would have... Well, I'll find out easy. I'll look at the manual. That should be obvious by looking at the schematic for the CRT. Copyright 69, main vertical amplifier. Yeah, I would not want to mess with any of that stuff. I'm sure this was all hand calibrated in the factory way back in the day. And look at those coils, just twisted pair, center tap. I mean, that's got to be super low inductance, right? So, the smashed part, what is it? It's the Y-axis alignment pot. And that might control some kind of DC offset to something. At least it looks very isolated. It's a pot held on with a nut, and on the other side is the body of the pot, and there's several wires going to it. So if I can find out what the value is supposed to be, I should be able to disconnect this and hook one up. I probably don't have one small enough to mount here, but I can mount it somewhere and just run the wire, hang the wires off of it, just to, you know, get it going, because that's probably one or several of the wires are shorted together. And that smashed body down below. For those of you not familiar, there is actually a Tektronix wiki, which has info on all the old school Tektronix scopes going back to the very first. And I do have, I believe, a 300 series in storage that one of these days I'll pull out, that I've never done much with. But for now, the topic du jour is the 454, so I got the manual for that. All 309 glorious pages of info. About 100 pages of how to use the darn thing, including theory. I mean, they really... It's interesting, they tell you how the thing works. Also... Not the greatest scan, but there are photos showing the accessories. Of course, I'm missing everything, but there is a front cover, and that's where you would store extra probes and stuff. Like I've noticed, there's a probe, I think, for power, which can, I presume, measure power of some sort. I don't know if it's RF power or something like that. And here they discuss that voltage. selector assembly we were just talking about. There is a fan on this, and it is pretty critical that the fan keeps working if you're going to operate this. So that's something else we have to be aware of. If the fan doesn't run, I can't leave this thing on for very long. So they go through all the specs, what all the basic controls do, and then they get into theory of operation. It's intense. So there's a reason why I use the digital scope I use, because it has a magical button called auto scale, which means most of the time it will figure out how all the controls should be set so that you can see what you want to see. These analog scopes don't have that. You have to know how to manipulate all the controls on the front panel to do what you want to do. And the higher end scopes can do an awful lot, far more than I am ever likely to need to do, but that's why these manuals are so friggin' complicated. And why they go into theory of operation and stuff, because you kind of need to know somewhat how it's working inside sometimes to get the most use out of it. So you can see several hundred pages of this stuff. So I can understand why it's daunting for folks to learn how to use a scope if this is what they were presented with. Alright, so I've already skimmed this ahead, so I know that the good stuff starts at around page 300 or so. Nope, you gotta jump forward a lot more. And there is a whole section on troubleshooting and a whole section on calibration, and as I feared, it's pretty complicated. I don't think I even have all the equipment to do it. But there is also a full-on parts list. So even like what motor they used for the cooling fan, and every single capacitor and resistor, and so on. Hopefully I will never need to use this info. Alright, let's get to the schematic, or at least to the block diagram. As you can imagine, this parts list is very, very, very long. Okay, block diagram. Finally, some good stuff. So one thing on the vertical preamps and amps, I'm only seeing Qs, and Q is the designator they use for transistors, and CR would be a diode, and that's for crystal rectifier or something, and why Q is a transistor, I'm not quite sure. But I don't see any tubes. That's what I was looking for. Why did I think there'd be a tube in there? Because I saw this on eBay. Selected 8393 new Vista tube for 453 and 454. Well, I've got a 454, so go figure. And apparently there's also some exotic tunneling diode that they use. And there's that set of refurbished bottom feet I can get. I can get a bunch of manuals. And here I can get a whole scope for 150 bucks or a best offer. Unfortunately it's $90 shipping, so that's the one downside. Yeah, these things are a little bit heavy. I mean, I'm not going to pay 300 bucks plus almost 300 shipping from the Philippines, of course. But if I see one that's near me or free shipping and it's kind of busted up, you know, I might go for it. Not a whole lot. I don't know how many of these. I mean, they made them for years, but there's only a handful for sale I see right now. Anyways, let's get back to this. So one thing I saw right away is there's only one set of deflection plates. Bam, bam. So they do use a chopper, and that's what this stuff is, vertical switching multi-vibrator. So we have separate inputs and separate preamps And then after that, there's just one vertical output amplifier driving those. Man, a lot of transistors. So why would they do that? To decrease the part count. A CRT with two sets of electron gun and deflection plates has got to be considerably more expensive. And having to have two of these exotic high-speed amplifiers is going to, of course, increase the cost. This is just too much for my poor brain to absorb. Luckily, I did skim through these dozens and dozens of pages of stuff. Finally got to some stuff I could wrap my head around. So here's the power supply. Pretty straightforward. Transformer. We got some bridge rectifiers, filter caps, voltage regulators, pass transistors. And there's our 75 volts and plus and minus 12 volts. So we're good on at least understanding that. And a little while later, here's all the, I think, front panel controls or something like that. Oh no, power distribution diagram between the various boards. Okay. And there's so many test points and test waveforms and voltages and such. Whew. ZX's board. Alright, finally. Here is the cathode ray tube schematic. Runs on 12,000 volts. It's got some interesting features because it's precision equipment. We've got to make sure that the beam deflection is perfect or as good as we can make it, so it has things like this coil around it for trace rotation. It's got the geometry correction, astigmatism, everything to make sure that that trace is perfectly flat, perfectly vertical, and perfectly linear, and no distortions, and nice bright sharp trace. What do we care about? We care about that. The y-axis align control. It's just a 5K pop between the plus and minus 12 volt rail. I managed to get the remains of the feet off, which let me free up the back cover. As you can see, is really mangled. And then I took a look at this pot, and yeah, there was no continuity between the terminals, so I disconnected the wires from those three. There was a fourth wire going up to the washer that grounds it to the chassis, and that feeds down to some wire going into the CRT, so I hooked that back up, and then I tacked in a 5K Allen Bradley mod pot to replace the damaged one. So I think we are good to go. Power cord, lost its insulation here, but it seems to be intact. I straightened out the pins at the other end. I think it'd be a good idea for me to get my PR57 though, rather than just jamming that straight into an outlet. So let me grab that, and then we'll flip this thing on and see what happens. Man, this thing is dirty. Some of the controls, like especially this one, looks like it's kind of off a little bit, or maybe the plastic is warped. It's not exactly concentric about the markings. Okay, here we go. Every time I look at this, it takes me a while to find the power switch again. It's way over here. So let's turn this guy on. Current mode, output voltage. 120-ish. Get to current mode, and here we go. Ooh, it's alive. Wow, that came up fast. Huh. Is that fan actually rotating? It is, I think. Dark back there. Hmm. Man. There we go. Well, built these things tough, I guess. Jeez, I was not expecting that. Okay, mode. We are just in channel mode, one mode. Let's go to alternating. So maybe it doesn't flip between the channels quite as quickly as I thought. Let's get rid of that illumination, that's kind of annoying. There's a light bulb up here that offers side illumination. Let me kill the overhead light, speaking of illumination. That's better. Let's get rid of that. Well, there's a BNC jack that says 1 volt cal, 1 kilohertz. So let's hook that up and see if it does something. Yes! It's a beautiful thing. See, this is where, if I have another scope, I hit auto scale and everything would happen. But no, I gotta figure out the controls and find the vertical scale that's best, and the horizontal time base that's best, and the trigger modes that's best. So obviously it's not triggering very stably right now. Okay, we got trigger level, that's not doing much. Sweep mode, slope, that's not much better. DC couplings, yeah, about the same. Triggering, a triggering source. Internal, I think that's right. Auto trigger. So I'm missing a knob on that control. Changing the slope works. Here we are a few hours and a whole lot of Q-tips later. Believe it or not, one way they would clean scopes at the Tektronix service facilities is to actually hose them down. They're probably using a special cleaning solution, or at least distilled water or something. And it's tempting to just throw this into the dishwasher, but no, I don't want to run the risk of damaging anything. So Q-tips and just some sparkle glass cleaner and went around everything. Then I got a little bit bolder and got out some Allen wrenches and started taking off the knobs and cleaning them. And it turned out they clean up extremely nicely, very nicely, and it's pretty easy to do. I used a toothbrush and some simple green and warm water, and that stuff just fell off right away. And likewise, this whole thing was very easy to clean. It was just superficial grime. Eventually, I figured out how to get this out. I figured there had to be a way for you to clean this bezel, so you push down and then the top tips out, and there's a blue filter plastic in there, so you can clean that up. It helps aid in the visibility. Unfortunately, the CRT is off a little bit. It needs to be rotated clockwise, like 1 degree. I do not know how to do that. Hopefully it's not too difficult. And it snaps back in. These knobs, it's weird. When you get them damp, they look gray, but they dry kind of white. I don't know if that's some film that developed on the plastic, or are they painted? I don't know. So those don't quite clean up so nicely, but everything else is great. I do believe that this plastic did shrink a little bit, this black clear plastic piece. Try as I might, it just doesn't quite line up as you go all the way around the dial, but it's close enough. So I tend to favor modern test equipment recently rather, simply because I don't have a lot of free time to work on projects. I might just have a half an hour and I just want to like flip stuff on it and just go. I don't want to have to let things warm up and check the calibration and zero and null things out and stuff. So that's why I generally use, even the newer stuff I have is 30 years old, but it's not 50 years old. However, the sampling scope I have, it's 30 years old, and it's got some limitations when you're looking at certain waveforms, like a video signal or a modulated signal in the IF strip. So, not in this video, but soon, I'm working on some projects, and I'm going to put both this scope and my digital scope side by side. I'll have a little shootout when looking at various more analog kind of waveforms and see how they compare and see why you might want to get an old scope, warts and all, and use it now and then. Now, I am not going to go through and fully calibrate this. Some of the switches seem a little dirty. I might try cleaning that. I joined a Facebook forum, and I know there's some online groups because I don't quite know how to service lists and like how to go about cleaning controls and stuff. I don't want to screw anything up, so for now I'm just going to leave it as is. Usually if I rock the control a few times, it'll do whatever I want it to do. So here's one last look at it working. I do have some reproduction feet on the way. Some or all of them are 3D printed, so I'm curious to see what the quality is going to be like. Generally this works. It can trigger, sometimes it's a little jittery, trigger plus minus. I mean, it basically works. So how cool is that? I'm going to keep cleaning it up a little bit more. I'll do another installment when the feet arrive, and then we'll do a shootout between scopes 20 years apart with similar bandwidth specs. But let's see what the actual waveforms look like.